that I'll share these recordings with you so you can refer them later also. Okay, I've just started the recording. So, sliding window, we will start with. So, we'll start with a very basic problem first, which is going to be, let me just put down the problem name here, which is maximum average subarray. This is a easy problem, but just to begin with, let's start with this and then we'll discuss some concepts and then we'll jump into further problems. So I would like you to open this question as well. Let me ping it on the chat also for quick access. And I hope you are able to see my screen. You can see my screen, right? So, all right. So basically, let me log in as well. Give me a second. Meanwhile, you can also log in to your lead code and logged in already. Okay, that's great. So I'm gonna comment. I think I have solved this problem earlier, so I'm gonna comment this everything out, and we'll start. We'll also switch the language to C++. Uh, okay, although language is immaterial, but let's use C++ for our purpose. Okay. Um, Cool. So let's go through this question. The question says that we are given a vector of numbers, and so it's an integer array basically, and we are given a variable k. The question says that find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. So I would like it's an easy problem. I would like you to think about it, and if it's fairly easy, I want you to code it up. But let's first discuss the approach. Can you go take a few minutes to understand the problem and then tell me what do you think about this? Mm-hmm. Hmm. Hmm. Yes. Hmm. Correct. Mm-hmm. Hmm. 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 Correct. Hmm. Right. Hmm. Minus one. Hmm. Hmm. Correct. I think that's awesome. So I think you're spot on with the approach, and I like it also. So can you? I think so. The idea is that just to give a basic idea, sliding. The reason it's called sliding window. First, we are picking a window of size k here, right? This is our window, and then we are sliding it one step at a time. So do some we slide it one step at a time until it reaches the end, and then meanwhile we do the computation to find the maximum average and return it. Like the question is asking that. So this is fairly good. Can you think of some corner cases in this problem? Let's say hmm, then it would k cannot be greater than length of the array, right? So that's yeah, it's a constraint also, but it cannot be greater, right? So whose length it is that find a contiguous subarray whose length is equal to k, right? This question can be made more complex by saying that whose length is we'll talk about the other variations as well as we go forward, but this is a fairly straightforward question. So how about this, like you start solving this. Maybe you can share your screen and I can. Yes. Uh, 1 minute. Okay. Yep.
Yeah, I think this can be 0.
Hmm.
And then sum is plus equal to nums r. Yeah. Wait, no, not nums for size. Right, like k. Yeah,
Mhm.
yeah,
So we are computing the sum for the given k-sized window,
yeah,
right? As a first step. That's correct.
yeah. And
Yes.
then average equals to sum. Wait, average is actually double.
Mm-hmm.
Yeah. So I say double average. Let's say. Let
Okay,
me.
here's a question to you. Do we
Yeah.
really need to compute average at every point in time? Or what do we care about?
Oh yeah, we just care about the sum. Oh
Right,
yeah, we don't even need the average because k is always constant.
right. So we can compute the average
Yeah.
at the last, right?
Yeah.
Yep.
Okay.
So,
Yeah, makes sense.
so we are just
So
looking
after
to maximize the sum, right? At this point.
yeah, then I say while because left will change accordingly. So I just say right is less than or equal to nums dot size minus one. Yeah.
Mm-hmm.
Or yeah. And I say sum is equal. Wait, no. Then I say sum is minus equal to nums left.
Mm-hmm.
Okay. And I say left plus plus,
Mm-hmm.
right plus plus, and then I say sum is plus equal to yeah nums right.
Hmm.
Okay, no, but I forgot one thing. I have to temporarily store sum somewhere.
Yep.
Yeah. So
Why do you need to temporarily store the sum?
because then we have to get the max. Like I can say something like sum is equal to max of sum comma
Yes.
sum. Yeah.
But
But like this is
you can't
temporary.
do that in the running sum, right? This is your running sum variable, isn't it?
Yeah.
So you should take a new variable,
Oh yeah, a
just
new
running
variable.
sum.
Yeah.
Maybe after
Oh yeah.
n
So
plus 5.
sum max. So maybe I can say int sum max
Yes,
equal to int min. Yeah.
correct. That's good.
Yeah. Then I say sum max is equal to max
Hmm.
of sum and sum max. Yeah.
Yes.
After this, I think it will already like once it exits the while loop,
Hmm.
it would have computed the maximum sum. So then we can just say, is it return? Yeah, return sum max divide by k. But like we actually double
Hmm.
is equal to sum max divide k. Yeah,
Hmm.
yeah, I think so.
Do you think are you missing some one
Yeah,
condition?
yeah, I think I'm missing something.
Can you think?
Because if right is equal to nums dot size minus one, and if I say plus plus,
Hmm.
it's going to give a problem.
Hmm.
So maybe I should minus two this.
Just 1 second. Let me. I was no. Why do you want to do this? Minus two.
No, because if I check for minus one, let's say it reaches index five for this. So
Hmm.
0, 1, 2, 3, 4, 5 here.
Example number one, you were saying.
Yeah, example number one.
So
It
five is
reaches
the
index
last
five.
index.
So 5 is less than 5
Okay.
because size is 6. But then I say right plus plus after that. So then I'll go outside the,
Um,
I'll go
okay.
outside.
I see what you're trying to say. So yes, so that is one issue. So how? What's the best way to fix it?
Yeah, I'll just put a minus 2.
One question here. Can you go scroll up?
Scroll up. Okay.
So why don't you see? You're not moving. How about this? Instead of using int I is equal to 0, I less than k I plus plus, why don't you just have, let's say, right is equal to 0 in line number 4, initialize to 0, okay? And then you say that until in the for loop
Oh,
in line
okay.
number,
Yeah, that also makes sense.
so your
Yeah,
right
then just
pointer
keep
will,
doing right plus plus. Yeah.
yeah, it will already automatically be the position where you wanted it to be. So in line number 4 you can start with right is equal to 0, because currently your window, you don't have a window, right? So your left right are actually indicating the pointers to the window, like what is the left marker of your window, what is the right marker of your window. Currently the window has 0 elements to begin with, right? So both are
Yeah.
pointing to 0 in that sense. So you can initialize right equals to 0 at line number 4, and
Okay.
then
Yeah, then this one I can
yes,
say,
you don't need a for loop, you can just say while loop while right is less than k, and you can say some nums of
yeah.
nums of right here, right?
Oh yeah, nums of right. And then right plus plus.
Then right plus plus. So once you come out of this loop, right is already pointing to let's say 0 to k
Then
minus 1 you have already covered, so it's already pointing to the next
K, the
k.
next element. Yeah.
So now you don't need to do minus 2, you can just still do in the line number 14, just in fact you
Yeah,
don't,
then we have to change these.
yeah, you just need to
Right.
shuffle line number 17 after 18, right? So you initially, so,
Really?
so in fact you, what you can do is you can put line number 16, 17 after 18 so that it looks so
Oh, okay. Yeah.
I mean anything is fine, whichever
Yeah.
sounds good to you.
So it just looks better here.
Yeah, and you can remove these extra blank spaces to keep it concise. It's fine
Okay.
just for the readability purpose. So
Yeah.
yeah, and I think this looks good, but still you're missing one small thing here. Can you figure out what you're missing? This won't, this would work for like, let's try to run it. You will, you will see.
Okay. Wait, I'll just run the test cases. It should be fine.
Hmm. Yeah.
Oh wait, what?
Okay. What's the expectation?
It's
12.75.
getting integer, I think.
Yeah. So do you know why is that happening?
Wait, no, I'm not sure.
So in
But
C,
I initialized it to double though.
yes, but the problem is that in C, in all programming languages, when you divide integer by integer, so sum of max is an integer and k is also an integer. When you divide integer with an integer, it will always give you an integer value. It will never give you a float value. So it is going to
Oh,
round off the number. So let's say you're getting 12.75, it is going to round off to
just
12.
flow rate. Yeah.
And then since you're initializing it to a double average, it is going to typecast it into a floating
Yeah, then
value.
typecast into float. So it'll just be 12.0.
Yes. So to handle that, what you can do is you can explicitly typecast one of the values, let's say either sum max or k. So you can do typecast of sum max. The way to do typecast is you can put a parenthesis before sum max, put a parenthesis. No, no, no.
Or like that, yeah.
Yes, and
Then
put
it's
a double.
float or double, right? Yeah.
That's it. Now try to run it.
Okay. Then I don't even need this variable though. But yeah, I think it's still fine.
Yeah, it's okay. Okay,
Okay, then I got one of them.
so one
But this
example.
other one,
Okay. Yeah. So what's happening? Can you figure out why is this giving you the minus? This is the int min value you're returning, right?
yeah.
Can you figure out why are you returning? Why? Is it returning int-min value?
Okay, let me see. So k equals 1.
Try to
So
do a
start
dry run.
here.
Yeah.
Yeah. So left is 0, right is 0. So while 0 is less than 1, I do this. So there's a 5 inside sum. And right is pointing to 1, which is out of index. Okay. Okay, then sum max is this. Oh, then it won't even enter the while loop.
Yeah.
Yeah.
Hmm. Correct. Sorry, I had a disconnect. Yep. Hmm.
Not going to enter the while loop.
Mm-hmm. N- No, so basically, yeah, so sum max, which you are doing in line number 12, yeah, you can directly say int sum max equals to sum, or you can actually say sum max is equal to, let's say, max of sum max, comma, sum. Like you can just copy the line number 19 at line number 12 as well, and initialize
Oh,
your sum
no,
max.
but this is where I am initializing sum max.
Yeah, it's fine, it's fine, it works because mostly
Oh,
it will never be equal to int min, right? It can never go
yeah.
below int min, so I think it's fine. This is good. So you're initializing your sum max with sum, and then so now you try to run it, it should work now. Okay, so it got accepted.
Yeah, I got accepted.
So don't worry about the numbers here,
Yeah.
25% or something. Sometimes these are skewed, so let's not
Okay.
worry about
Yeah.
that.
We can.
Does that make sense?
Yeah, it makes sense.
So
Sliding window.
we are done with this question, so let's jump into anything you would like to discuss for this problem, or shall we move to the next question?
Yeah, I think we can move to the next question.
Awesome.
Yeah.
So let's move to the next problem. The next question is going to be this was just for the starters. So now let's move to the next problem, which is going to be slightly interesting problem, and I'm gonna share this problem over here on the chat with you. So can you open this question? Yes.
Oh, longest substring without repeating characters.
Okay, so what I'm gonna do here is let's first discuss the idea about it, and then we will discuss the solution. So the question says that we are given a string, right? And we need to find
Yeah.
the longest substring from this string
Without
without any repeating characters. It's a very standard problem, but we would like to discuss two variations of it. One, so let's first try to hear your thoughts on it, and then we'll proceed. So what do you think? Have you seen this problem before?
okay. I've done something like this before, I think.
Mm-hmm.
Yeah.
Yeah.
Okay, well let me read it first. So let's say this. So how I would do it, maybe I'll go here, here, here. Then I'll go next. Hmm. Yeah, then okay, I might have some idea of how to do it.
Mm-hmm.
Okay,
Let's
so I
take
think
the approach first.
yeah, okay, so first okay, I'll start okay, left and right pointer again. I'll
Mhm.
put it at the first index.
Yep.
Okay, then I think we need to use
Mm-hmm.
sets. Yeah, but okay, that one will I'll see later. Okay. So first I will have both left and right at index 0.
Mm-hmm.
I'm looking at example 1. Yeah.
Mm-hmm.
So then I say, okay, now I say right plus plus.
Mm-hmm.
Okay, then I say get a B. And then I say, oh, B is unique. I haven't encountered it before.
Mm-hmm.
So then it's good. So then I'll write plus plus again. And
Mm-hmm.
I get a C.
Mm-hmm.
This is also unique, so it's fine. Now if I write plus plus, I'll get A, but
Mm-hmm.
I've actually encountered it before.
And how would
So
you
then
know?
that's the problem.
How
Yeah,
would you
so
know
for
that?
that, yeah, so that one That one I'm not sure, but I was thinking add each character to a set, but that
Right.
might be too slow. Yeah.
Wh- Why it would be slow?
No, wait, but checking in set isn't it like log n or something?
No, no. So sets are constant operations. It takes big of one
Oh, they're constant.
to add and to
Oh,
check inside the set. So they are constant operations, constant time.
oh, okay. Okay, then yeah, then I think I should use set. And I say, oh, if check if this character exists in this set.
Hmm.
If it does, then okay, that there's a problem, right? So
Hmm.
then I say, okay, the so far the highest is three,
Hmm.
the length. So then I'll store it in some variable, and then I say, okay, left plus plus because I'm checking for a next possible longest substring.
Hmm.
So then now left points to B. So then my substring is B C A, and
How
then
how would you know?
uh,
So here's the thing.
yeah now okay
So how would you decide to move your left pointer from A to B? Your left is at A,
yeah
right? And your right
yeah
pointer came at
is also at A.
is at also at A, which is at third index, and
Yeah.
left is at zeroth index. So now you find a duplicate, right?
Yeah, so once I find a duplicate, I'll move left.
But how long you have to move left? It might be possible that in this case the first A is present at the left pointer, the beginning of the left pointer. But it can be possible that this instead of ABCA, the string is, let's say, BACA.
PACA, yeah. So yeah, so I'll just keep moving left until I encounter. Oh yeah, like that. Okay.
So do you see like what I'm trying to say here? Like you will need.
Yeah, yeah, I can see.
So let me explain you the concept first, okay? Quickly, and then I'll let you write the code for it. So
Okay, so but can I try once? Because I
okay,
think I have something.
go ahead, go
Like
ahead.
because if I have A, right, then I can maybe somehow store the index of the previous A, something like that.
That also.
Because it's guaranteed, right? Because it's guaranteed that when I encounter a duplicate,
Hmm.
there has only been one of this letter before. So if I find that letter again, I know that after that everything is unique.
That's a good question,
Yeah,
but what if there are
like
more
that.
than what if there are more than one instances of this letter? Let's say we have A, B, let's say triple A altogether.
Triple A, yeah. But if it's triple A, right, then I then the right will move once, but the left will move again. So
Okay.
then it's still one, like that.
Mm-hmm.
Because look, the thing is, if I encounter a duplicate, it's guaranteed to be the second letter.
Mm-hmm. In
It's
the
not
in
like
the
a third
window.
or a fourth because our window works like that.
Yes. So our window, the property that we want to maintain in our window is that our window always holds the unique characters. If our
Yeah,
window has, let's say, if we are, so basically, just to add to that, let's say what we are trying to do here is we are trying to expand the window as much as possible. So we started from A, left is also pointing to A, right is also pointing to A. And we're looking to expand the window till the point, because the question says we need to find the longest window, right? So
yeah,
we will try to expand the window as much as possible until we encounter any duplicate. So there are two approaches here. I'll just tell you the approach, but I'll let you code it up. So the first approach which you described with the set is also a valid approach. That approach, how it works is we we add the characters in the window to the set. So let's say we started with A, so we add A to the set, then we add B to the set, then we add C to the set. Then as soon as we encountered A again, now we know that it's a duplicate character, right? So what we do is
yeah.
we keep removing all the characters from the window starting from the left pointer. So until
Yeah,
we have reached that duplicate character and we finally remove that duplicate character also from the window. And that point we know that now whatever window is remaining, that contains the unique characters
unique
again.
characters.
So
Yeah,
then we can go ahead and add that duplicate character from the right hand side into the window back. So basically the idea, just to explain, so initially the window is going to contain ABC, the set is going to hold ABC. As soon as we
yeah.
encountered A, we are going to shrink the window. So now we are not expanding the window, we are shrinking the window
The shape. Yeah.
Shrinking always happens from the left hand side. So we are going to move our left pointer one step at a time until we have encountered the duplicate character. And when we are moving the left pointer one step at a time, we also have to remove those characters from the set, because the set is a
Yeah.
reflection of what all characters are currently present in our window. So we just need to make sure that whatever, when we are moving left pointer one step ahead, we also remove that character from the set as well, because set is the window itself. Set is just a reflection
Yeah.
of what all characters are in the window. So in the first step we noticed left is pointing to a itself, and a is the duplicate character, so we just remove a from the set. And we also remove a, like we also proceed one step ahead. And now we know that since a was a duplicate that we had, that right pointer was pointing to, so now we are good, so we can safely add a into the window, so the window now becomes bca. And at
Yeah.
every point we are storing the longest window length that we have found so far. Now the longest window length is still 3 at this point, right? So bca. Now when we come to b again, same situation, so we remove the b from the left and add the b from the right, so it becomes
The right.
cab.
Yeah.
Then again the same situation, C again comes, so it will again become ABC. We remove C, add C, ABC. Now when the B comes, the second last B, so now the window is having A, B, C, currently three characters. As soon as we,
Yeah.
and the set is also holding ABC, right?
Yeah.
As we encounter the second last B, we know that it's a duplicate character, it's already there in the window, so we start moving the left pointer, we try to shrink the window. The first character is a, we remove a, but a is not equal to b, right? A is not the, this is not the duplicate character, so we still remove it from the window. Now the window is
Set.
and set also, so now the left pointer moves to b, and the window and the set is holding b and c at this point. Now still the set contains the duplicate character which is b, so again we keep shrinking the window until we reach that duplicate character. So again we remove this, so the next character itself is b that we happen to remove now. So now the window contains just c at this point, and now we happen to add the b from the right hand side, so now window will become cb. Is that making sense? Hello.
Hello.
Yes.
Hello.
Yeah.
Oh, okay. Yeah, I think I lost connection.
Okay, so did you, like, were you able to grasp till cb, like how did we reach
Yeah.
cb? Okay.
Yeah. Yeah. I got it.
A- and then the final b, similarly, we will remove c first, then we'll remove b first, the window will completely become empty, and then we happen to add b to the window. So this is one of the approaches. The benefits of this approach is it is a big of n solution, but the problem, one small issue, is that here we have to traverse the string twice. Like every character in the worst possible scenario will be iterated twice. One time when we add it
Twice.
to the window, second time when we remove it from the window, right? So we have a left
Yeah.
pointer and we have a right pointer. So but this is a O of n solution, and this is the most optimized approach in terms of big O notation. But theoretically and practically speaking, we can do it in a single iteration as well. um, the approach which you described, to some extent, using a, like, storing the indexes of these characters, right? uh, but first, what I would like you to do is, if you can quickly implement the set based approach. The reason is that I want you to be familiar with that approach as well, so that in case if so that you know that this approach exists.
Yeah. Okay. So I think I can start with a set.
Yes.
Yeah.
And
I think that's it.
just to tell you, in C++, there is a difference between unordered sets and ordered sets. So
Yeah.
generally, ordered sets are little slower because they need to order the elements also, but unordered sets are faster. So you
Oh,
can,
yeah. The hash tables. Yeah.
yes, so we can take a unordered set here.
Yeah. Even removing is O of one, right? For this
Yes, both removals and additions and checking, all three operations are O of one.
hash table. Okay. Okay. So then we have string s. So I say Uh,
How will you write
let's start.
for loop or while loop?
So there's a while loop. Yeah, but how do you check length of string? I don't remember.
Length of string, we can easily check that. You have the markers, right? Left and right markers. That's it.
Yeah.
That's your window, right? Current window. So tell me something. Let's say if your left marker is pointing at 0th index and right marker is pointing at second index, this is your current window. So what's the length of this window?
It's 2 minus 0 plus 1.
Yes. So length of your window is
Yeah.
right minus left plus one, correct?
Yeah.
So
Oh, okay.
that's
So
the
I say while right minus left plus 1. No?
why you're writing
No.
this way?
No, I don't know because I need to like get something like while like while right is less than
Less
the
than.
length.
Correct. So just say, okay, okay, I see. So s dot length. That's it.
Yeah.
So you,
Oh, s dot length.
yes. So
Oh,
there's an inbuilt function, a length function. So
oh,
s dot length. Yep.
yeah. While right is less than s dot length.
Hmm.
Okay, then. Okay, I got it. Now I say so left and right. Okay, so I can say elements dot. Is it insert? I think it's insert, right?
Yes,
S left.
it is insert. So you can say, but are you sure you are going to insert directly?
Yeah, we should insert like the first element first, right?
I mean, it's a while loop, right? So don't you think that, I mean, yeah, of course, for zeroth element,
Oh,
you will
okay.
insert.
That means yeah. That means this one have to insert outside.
But why do you, I mean, there's no need for that.
Or like
Why?
no need.
There's no need for that. You can just do all the operations. Your code should be as generic as possible most of the times. There's no need to handle it explicitly. So tell me
Okay.
something like when you are adding the element to the to the set, what actually are you doing here? Like what's the logical, what does it logically mean?
It just means extending the window, like just
Yeah,
seeing the next character,
so
like if it exists.
it means it's extending the window, right? You're adding the character to the window, correct?
Yeah.
Would you add a character blindly to the window, or would you check some condition before adding a character to the window?
Oh yeah. Like check for duplicate, like if it already exists.
Correct. So how would you check
Oh,
that?
so I just have to use right, and I can say if
Hmm.
like I say s right like does not exist like in
Yeah.
set. So I don't know how to say that though.
Yeah. So you can you can write so elements. So you can say elements dot find.
Oh yeah, this one. Okay, elements dot find
Find and you can
is equal to right. I mean equal to elements dot end.
dot end. So it means it does not exist.
Yeah, so basically when it finds this, if it reaches the end, then it's yeah obviously it doesn't exist. Yeah.
Correct. So this is the
So if
condition
this
for
doesn't exist, then I say elements dot insert s
hmm.
dot right or s right.
Yes. And what else you need to do?
Okay, once I insert, I think I just have to insert. Yeah, that's it. But then there's an else. If I found it.
Hmm. But before doing that, so once you know that it's a unique element in the if block, shouldn't you extend the
Yeah,
window?
yeah. Right plus plus.
Yes.
Okay.
And
Yeah.
also one more thing that you need to do there. It
There is.
so you in the if block, let's say it's a valid window, right? Because you're extending the window, correct?
Yeah. Oh yeah. Then the length.
It might
Oh yeah,
be
the max length. Yeah.
yeah, it might be possible that this is the maximum window as well, correct?
Yeah, makes sense.
So what you need to do there, you need to find the length of the current window and compare it with the maximum so far that you have found, isn't it?
Yeah, makes sense. Okay, so for that, I can add a max length.
Hmm.
I can put it into min first. Yeah, then I say
You don't need min, you can say zero because the length of the
is
window won't
oh
be
yeah,
less
of
than zero,
course.
right? So,
Yeah, okay. Then I say max len
hmm,
is equal to max of len and right minus left plus one.
good. Yes, that's correct.
Yeah, but if else,
Yeah. In else, then what do you need to do?
okay, then first now let us say why until we reach that element at right.
Mm-hmm.
Like we keep incrementing left until we reach that element in right at index right.
Yes.
So I say while another while loop will be something like this. While uh, I think it's s left
Mm-hmm.
is not equal to s right.
Mm-hmm.
Yeah, then I say remove it from the set and left plus plus.
Mm-hmm.
And then how do I remove? Is it just elements dot remove
Elements dot erase, and
or erase? Okay, I think it's just s left.
but don't you think you need to do this before incrementing your left?
Oh yeah. Okay, I would have figured it out.
And one small thing, why do you really think you need a inner while loop here?
Wait, do we?
Do we
We
really?
do, right?
What if we? Don't you think that we already have a while loop at line number 7? It should automatically handle it because in this else block we are not incrementing the right pointer.
Oh yeah, we're not.
So
Yeah, okay. So we can just say this. We don't need a while loop.
although it works also, but then your code will be much cleaner. So you don't this works, right? Because your left in the when you come to else, you will erase one element, then you go to the outer while loop, and again the right pointer is still there. You have not moved the right pointer in case if it's
Yeah.
a duplicate, right? So you keep on coming to this else block, keep on removing it, and then go back to the outer while loop. So this also works, right? You don't, I mean, even if you do a inner while loop, that also works. But just saying,
Yeah, but
you
we
don't
don't need it. Yeah.
correct.
Okay. So then if you do this just left plus plus, I think that's fine. And then
Yes.
we'll just keep doing it. Yeah, I think that's it. Then we just return max len.
Awesome.
Okay, so let's
Let's try
do
to run
this.
the, yep.
Okay, I
Uh,
got some.
can you go to the no no go in the code. Let's first see your code. So you are taking a window starting from left 0, right 0, and max length equal to 0, unordered set. While right is less than this, you're saying
Oh,
okay, current character
okay, okay.
string, and
Index 0 minus 0 plus 1. Yeah, but it's adding already.
one sec.
Oh, I think max len is 1, right? Oh, no, but it still doesn't matter.
No, it does not matter here. So you're insert. So you're saying that if the character does not exist in the window, then we insert the character first, and then do a right plus plus. Okay, which is fine. And then after doing the right plus plus, you are saying that the
Oh,
maximum
yeah,
length.
then, yeah, I think this one has to be before the right plus
Yeah, yeah.
plus.
So you can, or just say right minus left. Maybe don't do plus one here. Just say
Okay,
like,
but I think for next time, if I want to see it again, I'll
yeah,
understand it.
you can do it after line number 9, like before doing. You're right. Before
Yeah,
doing this, yep, that was the error. You can
yeah,
also, by the way, instead of checking this way, you can, one other option is because the length of your length, you need to find the length of your window, right? So the length of your window you can
yeah.
either compute it by doing the pointers like right minus left plus 1. The second option is you can also do set dot size, like because whatever the number of elements will be there in your set at this point, that is exactly the size of your current
Right,
window.
it's exactly.
These are just two
Yeah,
options.
that also works.
That also works, but
Hmm.
fine, whichever. I'm just telling you different ways.
Yeah.
खाना चाहिए बस मुझे भी नहीं
Okay, and these ones.
खाने के बाद खा लो ढक दो. So this works, right?
Yeah.
Awesome. Now let's think about optimizing the solution further, because we are going for competitive coding, and competitive coding, sometimes these constraints matter. So how fast our code is executing, right? So can you,
Yeah.
currently the problem is that we are doing two iterations here, isn't it? Like two iterations means it is a twice of n solution, like 2n solution, because in the worst case, every character will be iterated two times, one when we are adding it to the window, like from the right hand side, and second when we are
Oh, yeah. And then
erasing it
we
from the window. So in the worst case, every character is accessed twice. Can we think of a way in which we don't need to access every character twice, like we don't need to go back to the left and keep traversing one step at a time? Rather than that, we can just do it in a single iteration. And the hint about that is the approach that you were telling me earlier, using the indexes, and you were mentioning something that every character can only be.
Store the index.
Yeah.
Yeah.
So think about that.
Maybe a map to store and a character and index like that.
Okay, and what are we gonna do with that?
So maybe let's say we go to the first element A. So then we say, oh, it's unique. Or for this case, we can say if the map of A is zero. I mean, like it doesn't exist yet.
Hmm.
So the map of A doesn't exist yet. So I say, okay, A, like then I say map of A is equal to the last index, which is zero.
Mm-hmm.
Yeah, something like that. And similarly, B, map of B will be one,
One. Correct.
map of C will be two. But then once we get A again, then we say, oh, check. Oh, actually, A exists,
Hmm.
and its last index is zero.
Yes. Then what do you need to check here? What do you need to do here?
Yeah, so then we remove all those keys that have index less than or equal to A, like that of A, the
Why?
index.
Do we really need that? See, removal is what's taking us time, right? In the first place, because you were using the set before. In the set based approach, we were removing all the elements that were not part of the window anymore, one by one, and then removing it. So removal was taking time, correct? Every time you move your left pointer once and then you remove it, so it was a, like, you're removing all the elements basically which are not there in the window. But my question is, can we avoid removing the elements from the map and still, so here's a question: what if the map can still have ABC, and let's say the position of A is 0, position of B is 1, position of C is 2, and your left pointer is pointing to 0, right? That's where your window is starting from, and your right pointer now is at 0, 1, 2, 3. Right pointer is at third index now, right, which is A. You're trying to add A to the window, correct?
Yeah.
So what we're going to do is, the idea is that first we are going to check in the map, is this character exist? The answer is yes. But then we will also check that, is this character part of my current window or not? Like my current window starts from index 0, which is left pointer, and ends at index right, which is right pointer. So we are going to check that, is the occurrence of A within my current window or not, or is it obsolete? Like, is it present in the previous window, which is not even part of my current window? And the answer is yes, because A is, the index of A in the map is 0, which is part of my current window. So what we need to do, all we need to do is, we will update the index of A as 2 in the map. Okay, it was 0 earlier. We'll update the new index of A to 1, to 2, and we will directly move our left pointer one step ahead than the previous index of A in the map. So previous index of A was 0.
Oh, like that. Yeah.
Like
Then
we
our left will
are,
become one.
so left will directly become 1, correct?
and then the A will be updated to index 4.
2. Why 4?
No, isn't it
Sorry,
4?
3. Sorry, 3.
Oh, no, 3, sorry. Yeah, 3. Yeah.
Hmm. Yes. So next time, so let's see. I mean, so take an example. Like I want you to take an example. Let me give you an example. Can you write after line number in the quarter pad? Yeah. Scroll down at the end. Let's take an example. And first, tell me how it works. So let's write an example. The example is A, B, C, uh, D, C,
C.
and then E, then D, and A. So can you think of like tell me if you have understood the approach? I want you to do a small dry run. Dry run basically means tell me what will be the values in the map, how will the values of left and right will update. So let's start with the value of left will be 0 initially. So after line number 3,
Right is also 0. Yeah.
so you can write left is equal to 0, right is equal to 0, and map is empty initially, right? So you can write map is equal to empty flower braces.
Yeah.
Okay, and it's okay. Just put it. You don't need
Yeah,
to.
I mean, yeah, I don't need this. Yeah.
That's it. Now come to the next line. So now right is at 0. You try to add a into the map,
Yeah.
right?
So it becomes left 0, right 1, and
And
then map
hmm,
is, it becomes A 0. Yeah.
correct. So now let's do this and keep continuing. So in the next iteration, what happens?
Yeah. Then I get right is 2, and it gets
You
zero
can put a
1
comma. Yeah, put a comma.
B1.
Hmm. Okay.
Wait, no, I think, yeah, yeah, okay, makes sense.
Mm-hmm.
Then we get the same thing, but then right becomes 3, and then we get C 2.
Hmm.
Okay. Then we have right becomes 4.
See, the processing of right is happening
Yeah,
little
happening one extra.
later on, right? First, you are checking. So right becomes 4, correct? And now when the right becomes 4, 0, 1, 2, 3, 4. Yeah. What happens now? What's the character at this point?
The character is at C
And
at this point,
correct.
but then actually D will be added.
Didn't we add D?
No, I think we should have added A and B here, like this. Then here C.
Hmm.
Yeah.
Correct.
Then D here. Yeah, but now it's like that.
Hmm.
So
Yes.
now right is 4, then we get a C, but C already exists.
C already exists, right? So what do we do at this point?
So
See,
then we say,
just
yeah,
to tell you, there are two more characters before C, A and B, right?
yeah,
So in this approach, we don't want to remove A and B because that's time consuming. We don't want to revisit them
yeah.
again. Okay. So what do you think we should do here?
Okay, so for this, then I think we say left first
Hmm.
is equal to the last C plus 1.
Okay. What's the last C?
So last C was at index 2,
Correct.
so left will be 3, right is 4.
Awesome.
But then map A is still 0 because we're not
Yes.
doing anything with it. B is 1. Now C becomes
Four.
4
Hmm.
and D is 3.
Awesome. This is
Yeah,
perfectly
and
fine.
then size is still 1 here, like this.
Size is one here. So size we are computing.
Or, wait, no, 2, sorry, 2. Yeah, size is
Size is
2.
2, and then similarly you will compute the size at every point right above. So will that part will be same, like the logic will be same of
Yeah.
computing the maximum length. So I'm not worrying about that right now. I know you can handle that, but I just want to have the logic. Now what happens next?
Okay, so now our left is settled. So now we go for left equals 3,
Hmm.
right equals 5 now,
Right equals to
which is
5.
in E 1, 2, 3, 4, 5. Yeah. So map will have A0,
Hmm.
B1, C4, D3, and then E is 5.
Yes,
Yeah.
correct.
Okay,
Zero.
then after that, I'm just gonna copy this. Okay, then we have right is equal to 6. But when right is equal to 6, we have a D,
We have a character D, right?
which already exists. Yeah, which already exists.
So it exists, but do you think we need to check something, like, because it exists in the map, but it doesn't mean that it should also exist in the window, correct?
Oh, yeah.
So how, because
Yeah,
we are
yeah.
not
So
removing
we have to
anything from the,
check.
so how do we check that?
So, so we check for all those values that are within left and right.
Not, we don't need to check all values, we just need to check if the value of D is 3, is it
Oh, yeah.
between, is it greater than equal to left and less than right? So it is equal to left, right? Answer is yes. So now we are sure that D exists within the window, correct?
Within, yeah. So if it exists within, then we say, uh, so right is still 6.
Mm-hmm.
Yeah, but our left will be D plus 1, so 4.
4. Yes.
And then our last D will be at
6.
6. And
Awesome.
then, yeah, that's it. Yeah.
And then we have A also, right? Last character. What do we do
Yeah.
with that?
Yeah, so this is the one. So now left is 4, right is 7.
Hmm.
But the map is like this. Then we check like that.
Mm-hmm.
C4, D6, E5.
Okay.
But now we check, oh, actually A exists. But then this 0 is actually outside this range.
So
So that means it's not, so that means it doesn't exist within our window.
so we can safely add it, right?
Yeah, so we can just safely add it.
So what happens next then?
So our A just gets updated to 7.
To 7, correct. And then the
Yeah.
right will, no,
Yeah.
you will update A to 7. It should get updated.
Yeah, in the next line. Yeah. So A will be 7.
Okay.
Yeah, and then our right, yeah, that's it.
Will become 8, and then we will exit the while loop, because now right has crossed the length of the string, right? So while loop will get exited.
Yeah, so then our size is just 8 minus 4.
Yeah, like size we will definitely compute at every step. So but you understood the logic, right? So in this case, we are not going back, we are not removing the characters from the window, and it's a one single iteration, correct?
Yeah.
So it's a O of, perfectly O of n, like previous approach was 2n, and this is one, this is n. So let's implement this approach.
Okay. Wait, so can I go drink water really quickly?
Yeah, sure, take your time.
Yeah, okay, sir, I'm back.
Yep.
Yeah. Okay. Wait, so this code, do I just delete it or what?
Sorry. You can, okay, so what you can do is you can create a new method here, call it, you can just rename it to
Oh,
1,
okay.
length of substring 1, and create a length of substring 2. You can copy the line 3, yeah, full line you can copy, so that,
Oh, yeah, okay. I'll just name this 2.
yes.
Yeah,
And
okay.
hmm,
So we just do unordered map, right? We don't need a
yes,
real map.
we don't need any orderings. So when we talk about ordered map or ordered set, they are not O of 1, they are log n. So we should always
Oh,
use unordered map or unordered set, until unless we explicitly require ordering of keys.
Yeah. Okay. Then we have int left equals 0, right equals 0. Okay.
Hmm.
Now, while, yeah, same condition, right is less than s dot length.
Hmm. Hmm.
Now I say, okay, this, okay, let me split it first. So I say if, we how to check for the key, like if s right not in, or is it the same? Is it the same here?
Hmm. Okay,
If,
you want to know the syntax for the map?
yeah, like mp dot find,
Map dot find current, that
yeah,
strike not is equal to map dot end.
I don't have an extra, yeah, I think,
Hmm.
is equal to map dot end.
So it means
Yeah,
it's not
that
present.
means, yeah, not present. So not present means you, okay, okay, wait, I'll come back here.
Hmm.
Okay, not present. Then I say if else, if it is present,
Hmm.
if it is present, then I check if it's within the window. So I
Yeah,
say,
you can
yeah,
do that also, or you can
because I'll,
add this check in the first if itself. You can merge it with the or condition, because if it's not present in the window, then still you need to add it to the window, right? Like you need to do the same.
oh
If
yeah, yeah,
and else if
okay,
needs to be repeated, so you can just add a or condition here.
yeah, okay. So that means, or, okay, that means the thing I have to check for is if it is outside
Hmm.
the range. So how do I check that? So I just say fmp s right, yeah, the number is greater than or equal to left,
Mm-hmm.
yeah, and mp mps right is less than or equal to right.
So you don't need to worry about the. You don't need to worry about. I think you're checking if this part of the window. You're not checking the other case. Your condition is going to check that is this character part of my window. If it is a part of your window, you are not going to add it to the window in that case, right? So you need to check the reverse condition.
No, but isn't it like, because if it's not present, we're going to add it to our map.
Yes. So one option is if it is not present in the map altogether, the key itself does not exist, which is the first part of the if condition you did. The second part, you are saying that even if it's present in the window, even if it's present in the map, but the index is outside the range of my current window, correct?
Yeah.
And what does outside the range means? It means that if this character was seen earlier than the window even starts, so my window starts from left marker. If the character
Yeah.
found in the map, if that index position is smaller than the left marker,
Oh yeah. Yeah, yeah, makes
right?
sense. Oh yeah, that's what I was supposed to check.
Hmm.
Yeah. So smaller than. So I don't even need this and,
Yes, you don't need this. And there's one small
oh
mistake.
yeah, yeah. Okay.
Can you?
Oh yeah, left. Yeah, yeah. So,
Yes, it should be less than left. Correct.
so not present. Then there's just this else condition.
Hmm.
Yeah. So that means else it's present. Okay,
Hmm.
then that's it. Okay. Now I can come back. Wait, no, but before that, oh yeah, okay, never mind. Okay. Can, so I just say this. Now if we go back here,
Hmm.
that means it's not present. So I just have to set, so I just say mps right is
Hmm.
equal to right.
Yes.
And then I say max len, wait, no, before that, yeah, max len is equal to max
Hmm.
of max len and right minus left plus one.
Yes.
Then I say right plus plus.
Good.
Okay, but else if it is, if you know it exists, then you just put left is equal to MP S right
Mm-hmm.
plus 1. Yeah,
Yes. Perfect.
makes sense. Okay.
That's all.
Yeah, that's all.
And you just return your max length.
Okay, so I'll just name this one,
Mm-hmm.
the original. I'll
Sure,
try.
sure. Yeah.
Yeah. Okay, then.
Are you returning max length at the end?
Oh, I forgot. Yeah. The while loop ends here, so return max length.
Yes.
Yeah, okay, got
Works.
it.
Perfect.
Yes.
Awesome. So now, since you have solved this problem, now we'll increase the complexity a bit more. Let's try let's try more variations of this window approach. So I'm sending you one more problem. It's a premium problem. I'm not sure if you have a premium membership. Can you try this if this you're able to open this question?
Yeah, I cannot open
Uh,
this.
you have a student your ID, right?
Yeah, I have a student account.
So I think this is going to be pretty cheap. Like
No, but no, but the account I have is not student.
all features. No, I mean, okay, do one thing. I'm gonna send you my 1 second. Let me see if I can give you my account just to for so that you can see this problem. I would appreciate like I would prefer you to I mean after the session you can
Yeah.
take the lead code premium membership. It is $80 for the 1 year, or I think lesser than that for if you have a student account. So you can
Okay.
register with your student ID and everything. So I think uh, it costs less. But let me at least for this problem, let me see if I can do is give me a second with K at most K distinct characters. At most K distinct characters.
Let me see if it's on code breaker.
Yeah, it should be there on some other sites also.
Hey, what's the name? It's like at most K,
I forgot.
longest substring.
Yeah, I'm sending you this. I'm sending. I've got the problem. So here is it.
Okay.
The same problem happens on this Naukri Code Ninjas.
Code Ninja. Oh, but I have to log in though.
Okay. Is it Google login allowed? You can try.
Yeah. Okay, I'll use my student's account for this.
You can use Google login if you want. Sign in with Google.
Yeah, okay, got it.
Hmm. So now the question is changed slightly. The question says that we are given a string and a integer k is also given to us, and we need to find the length of the longest substring. But now we can have with at most k distinct characters. Okay, so the question says that we can have at most k distinct characters. We can have repeating characters now. Okay, the question is now changed a bit. Instead of having all the unique characters in the window, now there can be duplicates, but the
Yeah, but there must be at least at most K
distinct
unique characters. Yeah.
more than k unique characters not allowed. So basically, just to tell
Yeah.
you, let's say if we are adding those characters in our set or a map, as soon as the size of the set goes beyond k, just giving you a hint, or the size of our map goes beyond k, considering that we are the set or the map is the true reflection of our window. It means whatever characters are there in the window, they the same number of characters are also there in the set. So
Yeah.
so that is just one hint. So basically we can have at most k distinct characters. So can you think of the approach first, and then we'll talk about the solution.
Okay, let me think. Okay, I'll try the set implementation first.
Mm-hmm.
Okay, I'm thinking still.
So do you, are you sure?
Yeah, we don't need a set. Yeah, we don't need set. Yeah, we can use this the map implementation you told.
Mm-hmm.
Yeah, okay, wait. So
And why do you need a map, not a set? Like, can this problem be done using a set?
yeah, it can, but then we need to use that remove all the way also.
Yes, but are you sure this problem can actually be done with a set? Again, I'm asking the same question.
Set. Okay. Add this. Add this.
Think
Add
about it.
this.
Think about it. So when you have to remove, what, let's say if you have to remove, you have to shrink your window, for example, right? On what basis will you shrink your window? You will shrink your window of how many unique characters are there, correct?
Oh yeah.
Isn't it? Now let me ask you
Oh yeah,
this.
but then A can come after like a series of B's, so we won't
Yes.
know where exactly where
No,
to install.
it's not about the indexing here. It's not about the um, it's not about indexing. So okay, so it uh, one second. The question says that you're let me also read the problem once again. So you're given a string and k is equal to 2, then the substrings that can be are a triple b triple bc, and the answer is 7, correct? So these are the two longest substrings with the unique character count as this. Hmm. um yep. See, in, you might, we might need to count the frequency of the character in the window. um we might need to do that. So
Oh
because
yeah.
when you remove the character from the window, let's say you're removing the character from the window, then when you're removing it, you need to know, like, let's say if you're removing it from, if you're taking a set, just giving an example, right? If we are
Yeah.
taking a set, we don't really know that after removing this character, will this character still exist in my window or not? How would you know that? Let's say if you have a triple b, let's say you have a double b, and we need to
Yeah.
remove the first a now. So when we are removing the first a from the window, if you're just taking a set based approach, in the set you will have a comma b, right? These are the two keys you will
Yeah.
remove.
Yeah.
When you remove a from the left hand side, how would you know that is a completely gone from my window, or there are still some more occurrences left of a? And the answer is that you, using the set, you cannot know, like you cannot make a decision whether to remove it from the set at this point or not.
Yeah.
How would you know, like, there are more occurrences of a left after removing from the left pointer? So there might be more occurrences between of the same character between left plus 1 and until the right.
In the right. Yeah.
So we need to count the frequency of the characters also. And in this case, we do not really, so we need to create a map of a frequency count, basically, which should count, which should have like what's the status of our current window. In this particular case, I don't think the optimization using a single, like using a single iteration is possible. We may need to remove each character one by one, right? Because here we need to get to the k most, um, like at most k distinct characters. So even if we write the base approach, which is mimicking the first solution that we did using a set, so we need to mimic that solution, but that solution can be mimicked using a map here, not using a set. So
Yeah.
we will.
That's map.
Right. So did you get the idea? Like, the idea is that so let me tell you the approach a little bit so that you can try to think about it. I'm not going to give you the whole approach, but just a tiny bits so that you can start thinking about it. The idea is that we will look to expand the window. Okay, that's our first approach. So we keep on doing right plus plus, but at every point when we do the right plus plus, we add the current character into the window. Window basically means the map. So in case of this, if this character already existed in the map, then we just increment the frequency, which is the value in the of that character in the map, right? We just increment its frequency. If it was not there, we add this character into the map as a key, like the value will be 1 because it's a only one frequency at this point. And at every point when we add a new character to the map, we we first deliberately add a new character to the map, and after that we check,
Then, yeah, if
is
the
this
size is more than k.
exactly, if the size is more than k, then we shrink the window at that point.
Yeah, we increment left.
Yes, we increment left and shrink the window. Does that make
Yeah,
sense?
but we increment left to the next, like plus one of the last.
No,
Like for example, like if we reach C, right?
we are not storing, see, we are not storing the indexes here. We are not storing the indexes here in the map. In the map, what we are holding here, the frequency, not the index positions.
Oh, we're holding frequency. Oh yeah, we have to hold the frequency.
Is
Yeah, yeah. Okay,
is
okay.
that making
Yeah,
sense?
yeah.
It's a frequency map, it's not a index map. So there are two sort of maps. One is a frequency map where you count the frequency of each character and store it in the map. So the map is going to hold the see, map has a key and value pairs, right? Key is going to be the character, let's say A, B, or C, and the value the value can either be the index of that character, or it can be the number of times you have seen this character. So here we are using the frequency map.
But we can also use like the map of, like,
Index.
you storing the character of
Mhm.
the index of the, like, last position of a unique character.
Mhm.
Like if I for this array, by the time it reaches C, it will be like A equals 0 and
Correct.
B equals 6. Yeah,
But do you
and
think,
C equals 7, like that.
but the problem with that is, uh, what happens to the earlier bees? So let's say you have the bees before it, right? So let's say if you have to jump to the let's say you take two maps, for example, one index map, second frequency map. Then the problem that will happen is all the characters that you skipped, how will you update their frequencies in the frequency map? You need to update.
No, that, wait, we need a frequency either ways, is it?
You need both of
Why
it,
the,
right? You can't. You need the frequencies also here. You think about it. Take
oh
an
yeah, we
take
need to
an
get the
example.
size right.
Take
That's
an
why we need the
example.
frequency.
Yeah, so I'll give you a nice example. So let's write an example. Let's write an example. E C E
Okay, wait.
E C E C. Uh, okay. Then write B. Then E. Uh, double C and B A. Okay, and the value of K is 2. So
Okay,
try to see if whatever approach you have in mind, does this work on this example?
okay, let me try. So, wait, case 2, right? Okay, can. So go here. Once it touches this third one. Okay.
Do a
Wait,
dry,
yeah, no, it's still like this.
yeah,
Like this, like
do a
this.
dry run, do a small dry run with the, let's say, whichever, if you're taking a set or a map, do a small dry run and try to understand if this works on this case. If you want, you can make the input smaller for the time being, just remove the last 4 5 characters, in case if you want to start small.
Okay, wait, okay, but I'll see first, like this
Hmm.
first, yeah. So EC. So the last index. Okay, so it will be, okay, then my map is like that. EC, wait, then B. Okay, wait, then Let me just try something. Okay. So by the time I'll try my method first, yeah. So first will be 0, then my C will be a 1, then this will be a 2, this will be a 3, and then I'll get a B, which is index 4. That's a problem. So I go to the
So how did you know that you have exceeded K? Like you're checking the size of the map.
size of the map.
Okay,
Yeah.
so size of map is
So,
now 3, correct?
so then I go to the lowest index.
Lowest index of E
I mean,
or the highest
yeah,
index of E? The highest index,
yeah,
right?
yeah, the highest index of
Which is 2.
E. Yeah, but how do we know it's E? That's the thing. That's why I'm saying it's the lowest number in
So
the
you
map.
you know na E is pointing to 2, so that's your latest index of E, right? You have been updating E.
Yeah,
So E is pointing to 2, which is the highest index of E, correct?
yeah.
So
So then I say remove this. So
remove this key value pair from the map.
yeah, like this.
Okay. And
So
then
it just becomes E nothing.
E
Yeah,
nothing,
okay,
okay,
like this.
fine.
I get an E again. So my E becomes a 5. But there's
E
a problem
becomes
here.
okay. No, but how are you computing the length of the longest string? So what was
Yeah, left and right.
okay, do one thing. Take proper pointers left, right, do it because otherwise you will get lost like this. So step
Okay.
by step, you don't have to like do it systematically. So take left pointer, right pointer, and try to think about it. And I don't want you to rush. Take your time to think about why your approach may not work or may work because until unless you realize that yourself, I don't want you to mug up the solutions simply.
Yeah. Okay. So left 0, right 0. So then when I say right is equal to 1,
So when left is 0, right is 0, then what happens at that point? So you have to add something to your map, right?
yeah, we add this E.
E to the map. So okay, let's add E to the map. So E will become the pointer will become 0, correct?
Yeah, then when I say E right is 1,
Hmm.
C will become 1. When right is 2, the last index of E is 2. When right is 3, last index of C is 3.
Mm-hmm.
Okay. And now when right is equal to 4, I get a B equals.
No, but when you don't directly add, okay, you add B, but then this is not fitting, right?
Yeah, it's not fitting.
So what do you do at this point?
So at this point, I go to the last index of E.
How would you know that you have to remove E?
Oh yeah, wait no, I think this is where it fails because oh yeah, wait no, yeah, actually yeah, last index of E, and I know why it's E because it's the smallest number. So, but if I go to the smallest number among these three
That's
and then
not
remove
that's
that,
not the good solution because you don't. It's an unordered map, right? You should if you
yeah,
iterate the entire map, it's going to be of n operation every single time. It will become n square approach.
oh yeah, makes sense.
Maybe you have your left pointer, right? So are you trying to remove E, which is pointed by left?
Yeah, so that means no, I have to remove all the occurrences of E
Mm-hmm.
because yeah,
Okay.
okay, once I remove this part, then I will get okay then because I know then to set left to 3.
But what if my question is, how would you update C here? So C you're saying is pointing at 3, correct?
Yeah, but because that's the last found C, which is within this range
Correct. But
already because
but
we are
what
creating this.
but what if Okay, here's a question to you. What if the value of, let's say, if I change the input of a line number 8, instead of second C, treat it as E C E E. Yeah, just put E. Now what happens now?
Okay, let's try again. 0 0.
Hmm.
No. So I get E last is 0,
Hmm. Then 1.
then
Okay.
1.
Hmm.
Then I get a C
C
last is
1.
1,
Correct.
then 2, 2,
Correct.
3,
3.
3.
Correct.
Now if I get a 4, then this is 4. Then there's a problem.
Yes.
So then I see is the smallest of the numbers is C.
No, as I said,
Yeah, but that,
you should not be
yeah,
checking
but
that
that's
way, correct? And that
yeah.
itself, we were never checking in the first place, this part. In the previous question also, we never iterated the map to see what the smallest number, correct?
Oh yeah.
How did we take that decision which number to remove? How do you shrink the window? Like here we have to shrink the window, right? So on what basis do you
Yeah,
shrink the
so yeah, but I know that I have to shrink the window to whatever C has
No,
plus one.
no, you have to shrink the window from the left pointer, right? The
Yeah, the left pointer.
left is pointing to 0, which is pointing to E, correct?
Yeah, so I have to point it to 2.
Hello?
Hello?
Your voice was breaking.
Sorry.
So you have to point it to point to what? Should be pointing it to E plus 1, right? Like whatever's a
Yeah.
4 instead of Y to 4, right?
Yeah, but why 4? Because I just have to remove C though.
I know what you're saying, but
Oh no.
how would you know that? You getting it? This is
Yeah, I
this
get it
this
now.
approach. You
Yeah.
can't do it by storing the pointers. You can't do it by storing the indexes. Is that making sense?
Yeah, it's making sense. Yeah.
So let's try another way. Okay, let's use this map to store the frequencies now. Okay, so let's start from,
Frequency.
let's put 0 0 every all, and let's start with left equals to 0, right equals to 0 for now. Okay, so now the frequency of E becomes 1 because its right is equal to 0, correct?
Yeah, so like this.
Then what happens? Right will become 1, it will become 1, then C will become 1, correct? And then E will become, you can directly put 3, yeah, and just increase to
Yeah.
3 3.
So I'll just do one by one.
Okay, fine. And now right will become 4, correct? Okay.
Then B will become 1.
No, no, wait a second. You don't add B directly.
Okay.
So at this point, we see a different character. Yeah, we'll add it. You're right. So we'll add B. So B will become 1, correct?
Yeah.
Now we check the size of the map. So and A is not there, so you can remove A from the map at this point. There is no A. So the size of the map is basically 3 at this point, correct?
Yeah.
Which is more than 2. Yep.
More than K.
More
Yeah.
than K. So what we do is we start shrinking the window from the left hand side. Okay. And we keep removing the characters one by one until, and when we remove the
Until
characters, we also
yeah.
decrement their frequency from the map. And in case if the
Yeah.
frequency becomes 0, we have to remove that key also. Otherwise,
Uh,
otherwise it won't reflect the correct picture. So what happens now? You tell me.
so when I do this, my E becomes a 2. And when I increment left again,
Hmm.
then my this becomes a 0. Once it becomes a 0, I
You
remove
remove it,
it.
correct? And now is it perfect now? Like, is this what we wanted? The Is
Yeah.
it satisfying the constraints, right? So now we can go ahead and again start incrementing the window, right? Because now we have the valid window.
If I get a 5, then I get a
Yes,
3.
correct.
But if I get a 6, I get a C again.
You get a C again, right? So when you get a C, now again, now the window has gone beyond the constraint, right? So what do you do now?
Do this, do this. Yeah, then we get a 0.
Hmm. So when you get a 0, you remove it from the window, correct?
Wait, am I doing it right?
I mean, it's okay. You got the approach, right? The dry run can be
Um,
slightly in. It's fine. The purpose is not to. The main focus is to help you understand the approach part, right? The thinking process part here. So you got the approach, right? How we plan to do it, correct?
yeah. Well, actually, I wanted to do this kind of approach only, but I incorporated like some inefficient method of like checking for the lowest number. But actually, this also is the same thing, but they use frequency.
Yes,
Yeah,
here we need to use the frequency. If you do not use
yeah,
frequency, you will not be able to know that if this character has completely gone out of the window or still some occurrences are there in the window. How would you know if you don't store the frequency count?
yeah,
Because the characters can repeat here. In the previous case, we had to find only the substring with the unique characters. Like there was no repetition allowed in the first place. So as soon as we find it repeating, we would just simply move our pointer to the last known index and directly shift our left position to the one step higher, because we were not really caring about what's the frequency count there. We were only caring
yeah,
about that it should not repeat. But here things can repeat. The question inherently says that your window can have repeating characters, right?
yeah.
And
It
out of
says, yeah.
those repeating characters we need to find the k distinct at most.
Okay, yeah, makes sense.
So can we go ahead and do the implementation part?
Okay, let's try.
Yeah.
So first, I will initialize map character combined. As a int left right equals to 0. So max len again. Yeah,
Hmm.
we need that again.
And can you figure out some corner cases before starting this problem?
Corner case.
Hmm. What if, like, think on the values of k? What is, under what circumstance you don't even need to run any loops?
Yeah, if k is equal to 1,
If k is equal to one, then it becomes the same problem as the previous problem we did, right? Like, e,
uh,
k. No, sorry. If k is equal to one, then it will be one only every time. The answer is going to be one. So if no, my bad. Sorry, my bad. So k is
you
equal
know, it can't be right.
it can be a bigger window also, even if k is equal to 1. Let's say triple a comes, so that's k is equal to 1, right? Or
Yeah,
triple b, so the answer will be 3, because triple a triple b, the length is 3. um what Okay, let me ask you this. Can the value of k greater than the length of the string?
it cannot, right?
It cannot. It can be, right? Here you're saying that at most k,
Yeah, it can.
it
Wait,
can,
no,
right?
it can't. Right? How? Wait, if we have k equals to 6,
Yeah, and let's say window length of the input string is just 3, for
and we
example.
use this,
Let's say this is your string that is given, a triple a, and then b's and then c. Okay, so this is your string, and let's say the
but k
value,
is 9.
let's say the
If k
value,
is 9,
let's
yeah,
say 100. Let's say the value of k is 100. Then do we, what should be the answer in that case?
and it should just be the size of
Exactly,
the.
the size of the string, right? We don't even need to process it. We can return the entire string as it is, correct?
Oh. So I just have to say if k is greater than the length, then I just return length.
Just greater than, or do you think for equal to also we can do that?
Equal to
If k is equal to
A,
the
B,
length,
C, and 3. Oh yeah, if equal to, then it's also fine.
right? So
A, B, B, C. Yeah, okay. Okay, so
can we
then
handle that corner case?
if k is greater than or equal to strut or length, then I just say return length.
Mm-hmm.
Yeah, that's it for the corner case, right?
Yes. And in case if the value of k is 0, can k be 0? No.
No, it
Okay.
cannot,
Fine.
yeah.
If value of k is 0, then you can return 0 in that case directly. But that's not,
I mean, we don't need to do
we
that.
don't need to do that. Yeah, so let's go ahead with the solution now.
Okay. Yeah, I'll name this better frequency. Or I'll just keep it. It's fine. Yeah. Okay, then while right less than str dot length. Okay, so I say first because whether the size is greater or not, I'll still be adding. So I'll just say MP of
Mm-hmm. Yep.
str right
See,
is equal
you can
is plus
simplify,
equal to 1.
you can simplify this slightly. You can, because you need to deal with this character again and again, so you can take this character in a char variable. So just tell, you can say char current equals to, or char current is equal to
Yeah.
str right. So now your code becomes easy, so you just say map of c, and you need to use this character again and again. So one is, yeah, this is one first thing.
Equals to or plus equals to?
Plus equals
Because
to,
yeah, because it default 0, right?
it's default 0, so you don't have to worry about 0 part.
Okay. Okay, after this, then I check for the size. So I say if MP dot size is greater than K.
Mm-hmm.
Okay, wait, if it's less than K, we don't do anything, right? We just continue.
Hmm.
Okay, so then I don't need an else. So I just have to do this. Okay. So if MP dot size is greater than K, then I
Mm-hmm.
have to keep incrementing left.
Mm. So two things here. If mp dot size is greater than k, if it is less than k, then you need to compute the length, right? So there are two options. Either you can use inner while loop here, um, or you can use the same logic also which you're writing. So let's first write about the logic. So you're saying that if the size is greater than k, then you need to compute the left character and remove it from the map, like
Yeah.
decrement its frequency, right?
Okay, wait, then we say left. Okay, we got it. Then I say, uh,
And by the way, in this case is a slightly different case because here we are adding the character blindly to the, uh, to this. So you should, hmm,
okay, wait, never mind. I think this one I can ignore it first.
hmm.
Okay.
So what you can do
Yeah.
is, you should instead use a while loop instead of if condition. I'll tell you the reason why. So in
Okay.
over here in line number 12, let's convert it to a while. So until it is greater than k, then what do we need to do? We need to remove the characters from the left side.
Yeah.
Let's write that logic first.
So I say MP string left
Hmm.
minus minus. Is it? Wait, no.
Yeah.
And then left plus plus.
Yep. And you also need to do one more thing.
Oh yeah, once if yeah, then I say if
If the
this
count becomes
MP
zero.
string left is equal to 0,
Hmm.
then I just remove it. But how do you remove?
You say map dot array. One second.
No, I got it.
I'll just check the syntax once.
Okay.
Yeah, you can say erase. Same. So map dot erase, and just pass the character, the key, the name of the key.
Okay.
But do you think this will work? We are already doing left plus plus at line number 14, right? So
Oh yeah, then Yeah, it must be before this.
Hmm.
Yeah, that
Hmm.
provides this. Okay.
And
Yeah.
after that, what do you need to do?
But we have to always compute the size, like max length.
But where? Where will you compute that?
So we can just do it outside, right? Like max
Hmm.
len is equal to max len, and then right minus left plus one.
Yes, you got it right. Why? So first, basically, the here the idea is that we are first extending the window, and then while we are checking that after this extension is my window of the correct constraints. Is this following the constraints? If not, we'll shrink the window, make it under the constraints given, and after that we are pretty much sure at line number 27, 21, that the current window that we have is have the constraints satisfied. So now we'll
Yeah.
be in a position to compute the max length, and this is the reason we I did not ask you to use a if over here. So instead of
Yeah,
if
makes
you
sense.
used a if, you would not be able to compute this max length.
Yeah, we won't be able to because our thing is still changing. Our length is still changing.
Hmm.
Yeah. Okay, then after this while loop, I can just. Wait, this is O of 1, right?
What is
This
O?
line 15,
This is
the
O.
erase.
Yes. So anything you happen to remove from the map from the set, add anything to the map, add anything to the set. All operations in maps and sets are O of one. But remember, only for the unordered maps. For
The
the
unordered, yeah.
for the ordered maps, it becomes log n.
Okay.
Is this clear to you? Like what we have done here?
Yeah, it's clear. I mean, I also got to know why my method didn't work. Although I had the same idea, like I wanted to do this implementation,
Mm-hmm.
but I was trying to use indexes instead of frequency.
Um, okay, so I'll again try to explain you. So basically, the reason your method did not work is because you're
Yeah.
storing the indexes, right?
Yeah.
For when you move your thing to plus one, let's say, you are first of all not sure that you want to move the minimum thing, right? But using your method, you don't know that is this having the minimum index or not, correct?
Yeah. Correct. Yeah. That one we were not sure.
You don't know whether whichever character left is pointing at left pointer, is this the minimum index or not? There is no surety about that.
Yeah.
And
If we did that, yeah. Okay.
one more problem, even if there was a surety, um how about, let's say, if there were other characters in the hmm if there was a surety, then it would work, but there is no surety. That's the only constraint.
Yeah.
You could actually use an unordered map there, sorry, ordered map there. So ordered map, no, even ordered map won't work because ordered map does the ordering on the key, not on the value.
Yeah.
You want to do the ordering on the value, which is the index. And the ordering on the key would be like they will just simply arrange the alphabets. Like the A will be first, then B will be second, like that.
Yeah.
Is that making sense?
Yeah. It's making sense, sir.
So can you try to run this code?
Okay. Let's see. Run first. Okay.
Mm, I think you need to include that. It's a different terminal, no? Hash include.
Oh, okay. Of course. Okay. Do I have to do using namespace? No, right?
I, let's try. Let's try
Okay.
with this.
Yeah.
Okay.
Okay. Now if I submit,
Mm-hmm.
oh TLE.
Mm, are we doing right plus plus? I think we forgot to do the right plus plus after
Oh
line
yeah,
number 13.
yeah. I think we didn't do it. Yeah.
You can do it anywhere, like line number 13 or after 22, anywhere.
Okay. Oh, wrong.
Hmm. Oh, we are
We
not
didn't.
getting answers. Um, 1 second.
Oh, are we supposed to see out or is it return?
I think it should be return only because the output expects the integer. Can you see out something and see if it's happening?
Wait, there's a. This is the expected output. Wait, what is? Oh yeah. Okay, makes sense. What if I see out?
We are not returning, like our code is not returning anything. You can do both, like you can return also and just print also.
Okay, and I'll return also. Yeah.
Hmm. Okay,
Hmm.
can you go and see the expected output? uh,
Still no out.
I think there's some issue with this. Can you do a run? Is there an option to run the test case here?
Yeah, here custom
Can
test
you
case. Yeah.
put one test case just uh, okay. So in the input, yeah. So in the input, just put one. So these are like number of test cases being run. No, no, edit it.
Edit. Wait, how do I edit?
Just copy it. Copy it. There's a copy option. Right.
Oh,
Copy. Go to custom test case, paste, and now edit it. So just take one example. Put one here. And what is the? This is I think value of k. So you can remove everything. Yeah.
yeah.
And try to
We'll use our.
yeah.
We will use this one only. 7. We'll target our 7 here.
Okay, yeah, you can change your output 8.
8, 8. Like why double? Oh yeah, because I see out.
You are see out.
Okay, but it's still giving 8. Like
Yeah, the reason is we are doing max length of right minus left plus 1, and we
oh
are
yeah, but our right is
right.
already plus.
Yeah, so you can increment right
Oh,
later on. So yeah, that's the small change.
let's do like that. Yeah.
Yep, now run it and then try to submit it after that.
Okay, then it should be fine. Okay. Now let's submit.
Okay, so it works. Okay, large test cases so accepted. So let's, I think we have small time, maybe 10 minutes remaining. I would want to, I'll give you some homework problem also, but I'll give you one more problem if we can squeeze in one more problem to see. I think, sorry, minimum window substring. It's a lead, should be there on lead code. So yeah, it's a good question. I've sent you the question. Can you go through this question and see what it asks?
Okay, wait, let me see here. So S and T of lengths M and N
Hmm.
and return a minimum Windows substring
Hmm.
of S. Okay, wait, S is this, T is this, okay. Such that every character in T, including duplicates, is included in the window. And if there's no such substring, return empty string. Oh,
So just to since we are a little short on time, so I'll explain you the problem. I'll summarize it for you. There are two strings given, s and t. S is the largest string. Okay, think of s as a bigger string and t is a smaller string. Now we need to find the window within. We need to find a substring of s such that that substring contains all the letters of t. So it means we are trying to find all the letters of t in s,
In S. Yeah.
but we are not really required to get the ordered, like it doesn't have to
No
come.
order, and it can have extra characters as long as it's
Absolutely.
minimally like ABC. Actually,
Absolutely.
strictly ABC in any order. Yeah.
In any order, and it can contain some extra characters also which are not part of t. uh, and we need to minimize this window, so we need to return the
Yeah.
smallest such window in s which contains abc. Is that part clear now?
Yeah. Makes sense. Yeah.
Okay. And it's given that the length of there is no constraints on m and n, but then you can assume that the length of sorry, t s and t, so length of t should always be smaller than or equal to length of s, right? If
No, they didn't say that though.
they didn't
There's
say
a
that, but
test case here.
that's what we can assume, right? So if it's
No,
not
there's
true,
a
then we
test
can.
case here though. Like the length of T is actually larger, then we can just. Oh no, but that's an edge case, right? Then we can just say if T length of T is larger than S, then we
We return
return.
empty because
Yeah.
there is no possibility you cannot find this
Yeah.
in s, correct?
Oh yeah. I'll just write this one first. So if T dot length is larger than S dot length. Okay. Yeah. Anyways. Yeah. Okay. Yeah.
Hey, sorry, I'm back.
Okay.
Yeah, so what have you written? If t dot length is greater than s dot length, then return empty. Cool.
Yeah.
What do you think? So, before jumping into the code, let's first talk about the approach, right? I know you can
Okay.
code, but what's the approach? How we can do that? How you will be able to find that which all letters of T are in S?
Okay. Let's try this. So I'll go for A
Hmm.
words. Yeah, but then once I use up this A,
Hmm.
I have to like use it up from T also. So I have to expect a B and C minimally
Yes,
like that.
correct,
So then I keep going one one. Then I see a B.
correct.
So then I used up B
Yes,
and I have to expect a C.
correct.
So then I go again and I expect a C. Oh, I found a C.
So
Okay, so
when
then this is my one possible
window,
window, which is length 6.
but is it smallest? We don't know, right?
Yeah, we don't know that. So then we say, okay, now let's wait. So then I go to the
Shrink the window.
yeah, shrink the window until I get because I lost A, right? So then I add back A, so there'll be A in T, and then I go until B
No. So okay, here's the thing.
like
when,
that.
when you
No?
no so first thing is you get the minimal window which has all the characters of t, so a adobe c, like till this point. Okay, now now we know that we have got a window, but we have to minimize this window, so there might be some extra characters in the beginning which we can remove potentially. So we'll do that. We'll try to remove a, but we can only, the condition is that the way this window algorithm
Oh
works,
yeah,
you can.
because if an A exists after, then only we can remove it.
Yeah, so if you remove
Yeah.
A, you will be one short of letter A from the desired window in T, because now in your window, in the current window, you have only one occurrence of A, one occurrence of B, one occurrence of C. But when you remove A from the window of S, you try to find the smaller window. In process of doing that, now you have zero occurrences of A, but the desired occurrences of A was actually one. So now you don't have the privilege of shrinking your window further. So you will stop at D. So your left is going to point at D, your right is pointing at C, and you're going to extend the window again as far as until you get all the desired characters of T. So the
Yeah.
remaining character is A. So now we will. extend the window to ODEBA. So we will, the next window will be starting from D, ending at the third last character A. Okay. At this point, we will try to now optimize the window by shrinking it, because we have found the desired number of characters. Now we can shrink the
Yeah.
window, so we can remove D, we can remove O. Can we remove B? The answer is yes, because there is one
Yeah,
more
because there's
character.
already a B.
So now
Hmm.
you're trying to get the idea that we might need to store the frequency of characters also, right, in the window. Just the
Yeah, we need
positions
to.
won't be enough. You need to know that if there are more occurrences left. So now we can remove B, then we can remove E also, because E is not needed. So then
Yeah.
we, the string will become CODE BA, correct? This is the string. And then we remove C, but as we remove C, we will be short of C, and then the window will become ODEBA, and then we'll expand it to NC. So the window will become ODEBANC.
See, and then we can minimize it again.
Yes, this is how we will.
Yeah, so that's what I was trying to say, right? I mean, when we got this, I said we can just skip A and go to like the next, because let's call these significant letters. So I said
Yes.
go to the next significant letter
Okay, got
after,
it. Got
like that.
it. Yeah,
So we can just straight away go there. So we get B, E, C, and
how
then we
would you
find an A.
how would you straight away go to B? How would you know that B exists there?
Okay, yeah, that's also a problem. Yeah, like okay, so that's the thing. Okay, then I thought of another way, right? We got A until here, right? Then now I say, okay, let's extend this window. Then I say O, D, E. Oh, then I see a B, right?
Hmm.
But I see a B, but my first significant letter is actually A. So I haven't found an A yet.
Hmm.
So then I go here ODB until A. Then find an A here, right?
Hmm.
And I say, oh, actually I can remove all the occurrences of A before this.
Right.
So then I say it becomes this, like that.
Hmm.
But then I realize I got an extra B. So I can go until I remove B. So I can go here like this. And then I can also remove E because it's insignificant. So I get this,
Mm-hmm.
like that. Then
Right.
now my first significant letter will be C, right? So then I'll extend the window, go to N, C. Oh, then I see a C. So I can remove C and go to the next significant letter, which is B. So then I get B, A, and C.
Hmm.
Yeah, and then out of all of them, I find the smallest one, and then yeah, this is the smallest one. So I output this.
Mm-hmm. Right.
Yeah,
So can you try to code this up?
yeah,
First of all, what are we going to store in the map?
yeah. The map.
Mm-hmm.
Okay, I was thinking indexes, but I need to think about it. Like index of the uh, significant letter. Like when we had this.
See, I'll tell you one hack. So when we are dealing with the frequencies, don't worry about the indexes at that point. Even
Okay.
even the approach that we did, we are doing two iterations. It's fine. It's still O of n, correct?
Yeah.
After, if you store the indexes, then what are you going to achieve? You're just going to achieve one reduction of one iteration, right? One lesser iteration. So try to do the code with at least with a basic, with let's say two iterations, using the, you are adding to the window and removing it from the window in a very
Yeah.
clean way. Once you're able to do that, then you can try to optimize it. So, and generally speaking, whenever the frequencies are involved, then indexes won't work. Like, you don't need to take indexes at that point.
Okay. Sure.
And here also, you will need to account for the frequencies, because the string t can have repeated characters also. It's a very simple example they have given. But imagine an example where there is double A BC. So T is equal to, yeah, like the value of T is double A BC, for example. So I'll give you I'll give you a brief idea about the approach. You can try to code it up maybe as a homework. So we should first calculate the frequency map of T, not S here. Okay, we'll calculate the frequency map of T. It means that we'll process the string T earlier and store its characters in the map and their frequencies. Then we start the window on S with left and right pointing to 0, and we'll be iterating on S. Now we don't have to iterate on T because we have stored the letters of T in the map,
Frequency map, yeah.
in the frequency map. Every point we find a character. So let's say A is we find the first character. Every time we see a letter, we decrement the frequency in the frequency map. So now and also we need to keep a counter, like how many characters we need to still find. The number of characters we need to still find will be equal to the length of T. The length of T is 3 to begin with. So it means we need to find three new letters in S, like three, at least three letters in S, and those letters are A, B, C. And like so, the content of those letters are given by the map, and the number of such letters we need to find will be given by this count. We cannot rely on the size of the map. The reason is that the letters can be repeated. So if the letters are repeated, the size of the map is still going to show 3. But let's say there are double A, B, C. So in that case, we need to find 4 letters of
Yeah,
in the window, and we can't really go and like check through the window again and again that have we found all the letters, or we can't really go and scan the map every time that, oh, is the frequency 0 now. So the frequency map will indicate that how many what the frequency of each letter in T, and also it will in a way also tell us subtly. So in a subtle way, it is also telling us how many characters are we, like what's the frequency of this character that we are currently short in the current window of S. So when the frequency of A is 1, it means that we are short on one occurrence of A in the string S. Is that making sense?
yeah. Okay, making sense.
And every time we encounter this character, we check it in the map first, like is this key present in the map, like is this character part of the map itself. If this character is not a part of the map, then it's a insignificant character, it's not a significant character, we can just simply, we don't care about it. But if
Yeah,
it's
we can ignore.
we can ignore it. But if it's a significant character, by checking that if it's present in the map, then, and if in case if we are accounting it in the window, in case if we are adding it in the window, we should decrement its frequency. It means that we are adding one more occurrence of this character in the window. In case if the frequency goes zero, becomes zero, it means we have all the occurrences of this particular character in our current window. And every time we decrement a frequency, we also decrement the counter.
Yeah,
Initially
the
the
count.
counter is 3, so counter will become 2, then 1. But there is a edge case. The edge case is, what if there are more occurrences of the letter than desired in the string T? Like for example, you noticed there were two B's, right?
Yeah, there were two B's. Yeah,
So what will happen is when we add the second B into the window, along with imagine the first B is also existing. So initially the window is ADOBEC. This is the first window that we will get. After that, we'll try to shrink the window. But once we have this window ADOBEC, the frequency of all the letters will become 0, because it means we have found all the letters ABC in the window and we are not short upon them. There is
yeah,
no,
we're not short of them.
we're
Yeah,
not short on them. But now we try to optimize the window, so we remove A. As soon as we remove A, we check that is A the part of, is A a significant letter. The answer is yes. And if we are removing a significant letter from the window, we have to increment its frequency by 1, because we
by
are
one.
having a one shortfall after that. So now the map will become A1, B0, C1. And
See, one.
as soon as any frequency comes in positive, let's say A is becoming 1, we also need to increment our counter. So counter will become 1. Is that making sense? Counter is like what's the total number of characters we are short in the current.
Oh, okay, counter. Okay, yeah.
Is that making sense?
So short of one,
So we are short
A
on
and counter is one. Yeah, okay,
counter
makes
is one.
sense.
So as soon as the counter reaches zero, that we will record that length of the window. So initially the counter became zero when A D O B E C, when the first window was found. Now we remove A, the counter again becomes back to one now, and now the string, the window is D O B E C. But now since we are short on one character, we'll keep extending the window until the counter becomes zero again. So we'll keep extending the window. We'll add O, then we'll add D, then we'll add E. These are all insignificant. These are all not significant characters, so
Yeah,
we ignore it. Then we add B. As soon as we add B, we have to update our map. But what happens in the map?
we have two B's. Yeah,
The frequency of B was already zero, right? In the map currently,
yeah.
frequency
So
of
then we put a negative one.
we put a negative one. It means we have extra B, which is fine, but we need to denote that by putting extra, by putting minus, like we'll decrement it. So it means we are not short upon it, we have one extra, so it will become -1. But here's the thing, if by adding in case if the frequency becomes -1, we do not decrement the counter, so counter still remains 1. Is that
Hmm, yeah,
now
makes
when
sense.
we add A, the next character is A. As when we add A into the window, now at this point, the frequency of A was zero earlier, right, in the window. Now the frequency of A will become, um, sorry, the frequency of A was one earlier because we were one short upon A, correct?
Yeah, we are one short. Yeah. So
Now
then when we add this A, we get zero.
zero, and as soon as like when we, it's not negative, right, it's still zero. So if when we are adding a character and decrementing the frequency, like decrementing the shortfall count, so and if it's not negative, we also decrement the counter, so now the counter becomes zero again. Is that making sense? So
Yeah, the counter is zero. Yeah,
it means we have found a new window starting from D. So D O B E C O D E B A. This is our new window. So we record its length, and now we try to shrink the
shrink this. Yeah.
not A. A is not
Oh
there.
yeah, without this. Yeah, without the D.
So now we try to shrink the window. We remove D. D is not part. So D and O we can safely remove.
Put it like this.
Now we remove B also. Now when we remove B, we
Can remove B because it's negative.
the shortfall, now the value frequency will become zero at after removing B, correct?
Yeah,
So we do not, so it's since it's zero, it's not gone greater than zero, so we do not increment the count will still remain zero because we are not short
yeah,
upon B now. And then we remove E, and after that, so and at every point we are storing, we are having the length of the, so this is the minimum window that we have found so far, COD EBA.
yeah.
And after that we try to remove C, but when we remove C, it will become 1, like the shortfall
One.
will become 1,
Yeah.
and
Counter is also one.
counter is also 1, right? Now you're getting it. So
So we
now
just add.
extend,
Yeah,
until we get the C, right? So ODEBANC. At this point, we have got the counter back to zero, and the short there is, and all the frequencies are zero, are exactly zero at this point. So now we try
yeah.
to shrink the window. So now we can safely remove ODE, and what
So
we are
we
left
get
with is
B and
C.
C.
And now when we try to remove B, then we have one shortfall of B, and then we try to extend the window, and we hit the reach the end of the string, and the code
Yeah.
will. So this is the dry run or the explanation part of it. Is that making
So basically, our main check condition to like shrink the window is if counter is zero and every
sense?
frequency in the map is also zero.
See, if counter is zero, all the frequencies in the map will be either zero or less than
Or
zero.
yeah, or less than zero. Yeah.
We
So
don't
at most zero.
we don't have to manually go and check for each frequency in the map because that will be additional time complexity. That's why we are keeping a counter. Is that making sense?
Yeah, that's why there's a count. Oh, so that's why there's a counter. Yeah. So
Otherwise,
what check? Okay, okay, I got it. Got it. Yeah.
you need to go and check for each frequency, each character frequency in the map, right? And that will be like the length of T. So let's say the length of S is M, length of T is N. Your program is going to become M into N instead of M plus N.
Yeah.
So right now the program complexity will be m plus n, where why m plus n, because we are processing the string t in the very first time, like we are doing a pre-processing by storing the frequency count in a map, and then we are iterating on s, so the total time complexity is m plus n.
Yeah.
I hope this is clear, the approach is clear, right?
Yeah, the approach is pretty clear. Yes, I'll try it also.
If you have time, I mean, I need to go somewhere, but I have like 5 minutes. If you maybe uh, I'll try to stay for the next 5-10 minutes, so can you try to implement it? I might not speak a lot, so I'll just see you, I'll observe you, code it up.
Okay.
You're clear with the approach part, so I think all is needed is just to code it out, and coding is not very difficult, it just the approach part was difficult, so let's see.
Okay. Then I also have counter for later. So I say for every. Okay. We need a 1 1 1. Okay, got it. Then so I say, okay. So I say right s dot length. Okay, well, right is okay. Okay, got it. Then I say, oh, it has been unordered. So I say check for the thing. Check. Okay, so if
Hey, I'll be back in 10 minutes. You keep coding it. So try to map the logic slowly. It should it should come to you. So I think you have
okay,
created a map. Now you're iterating the string. Yes. So in case if it's in so first thing that we need to do is we need to no, you don't need to do anything like that. You just need to check that if this character, if s right is part of the map, yes, correct, that's what you're doing.
yeah,
If this is not a part, you're doing, if it's a part of the map, right, then you
yeah.
should
Then I say,
decrement frequency first,
yeah,
map
s
of
right.
s right minus minus, and then you need to check that if this frequency is not negative, then you can also decrement the counter.
Oh yeah, if oh yeah, then if it's non-negative, yeah,
If it's not negative, if it's negative, then it means you are having extra characters, right?
yeah,
But you have you no, not count.
yeah. Negative means you're having extra, so
No,
that's why like
you should do counter minus minus, not plus plus. You are
We really.
Counter is, what is counter indicating? Like how many characters you are short upon, right? So you have found a character,
Oh yeah, yeah.
you have
Okay.
added it
How
to
many
the
are short?
window, so you are reducing the shortfall by one. And I think in the first place, in line number 10, you should also increment the counter, right?
Oh yeah. Okay, that's why. Okay, that's why I was getting confused.
So
Okay.
counter is the total number of characters from T that you need to find in S. As soon as you find one of the characters in S, you decrement the counter, right? In line number 18.
Yeah. Okay.
Making
Okay.
sense?
So after this, this is adding all the significant characters like this. Okay.
Yes.
Then I say okay, but if it's not, if it's an insignificant character basically, then I think you just add it. So you just anyways write plus plus,
Yeah,
and
it will
then
automatically get added. You don't have to like worry about that. So write plus plus you do, that's good. But before write plus plus, what do you need to check? Can you think of that? So you have added the character into the window, correct? What
yeah,
if you we need to shrink the window also, isn't it?
yeah. So that one you have to check for.
So what
Yeah.
will be the
So
condition?
yeah. So the condition is if counter equals to zero, then you want to start shrinking.
When counter is zero, right?
Yeah.
So you should say while, not if. You can say
Oh
while,
yeah. While yeah, yeah.
while counter
While
is zero, you
because
keep shrinking it.
so I say left plus plus,
Before
but
doing left plus plus,
wait.
you need to remove it, right? First,
Yeah. So first we have to do MPS left. Okay. And this one you want to plus plus.
you're getting
Okay,
confused.
no, no, no. You have to check first if it's a significant character.
Yes, that's the
Yeah,
first thing we need to check, right?
yeah.
So how do we check that? If this
Just
current character, so you can say if s of left, yes.
yeah,
So yeah, you can enter it and then put everything here. So now you need to first do, um, if it's a significant character, now you need to, what do you need to do now? So you're removing it from the window at this point, correct?
yeah,
So when you remove it from the window, you create one extra shortfall, right? So you say s left plus plus, and after
yeah.
getting the shortfall,
And then you counter plus plus,
no, no,
right?
no. Do you
Is it?
can we blindly just increment the counter here?
Wait, then.
Under what condition we will increment the counter?
Oh yeah, when we run. Oh yeah, only if the frequency hits zero.
No, if we create a shortfall of that character in that window.
Yeah. So
When is a shortfall? When the value is actually 1, at least greater than 0. So if
oh
it is
yeah,
0,
greater than zero.
if the
Oh yeah. Okay. So then if that uh this yeah is greater than zero, then I want to
then you only then you increment the
counter.
counter. Is that making sense?
Yeah, yeah, making sense now. Yeah, else you just want to add plus plus because yeah.
There is,
If not, you just left plus plus in either way, either case.
yes, you have to
Yeah,
do it in both the cases, right? So not, so you can, yeah, so you can do left plus plus.
yeah, and that's it. And then once counter hits one, then it will just
Yeah,
repeat this outer while loop and do its thing. Yeah,
yeah,
but then now I have to store the length or the or the
yeah.
or
So
the whatever.
so figure that logic out. Where do you need to store the, you need to store the length also, and you need to compute the length every time. Like have we find the minimum a better answer, and need to update
Yeah.
the answer, right? So you can take the length.
Yes. So yeah, that will be after this loop. After this loop.
No,
Yeah.
that will be in the loop, because if you try to do it after the loop, then what will happen is counter will not be 0. Counter will be more than 0, right?
No, isn't it after this mini loop?
You
This
can do it.
inner loop.
You can do it within the loop also, right? Every time if you check what's the, how it will hurt you.
Okay, yeah, makes sense.
See, within the loop, you're sure that the counter is 0. So before, in fact, before increment, before doing any if condition check, you should do that length part, because now you know that counter is 0, so it's a valid window.
Oh yeah, it's all valid. Oh yeah, okay. So then I say if.
you,
Okay, wait, that means first I need a temporary string.
you can just take a result only, no? Result is equal to initially result is equal to s. Don't need a string, you just need to
Yeah.
okay, you need to return the length of the
We,
okay,
we need to return the string.
we need to
Yeah.
return the strings. Okay, fine. So
Yeah.
hmm.
This. And then we also have int min length.
But better thing is to, rather than storing the string, we just need to store, we don't need to store anything like that. We just need two pointers like left min, like min start and min length. We just need two things, min start and min length. You can say like
Min.
start min and length min.
Okay.
Start min equals to 0 and length min, let's say length min is equal to int max or
S dot
s
min.
dot length,
Yeah.
yes, to begin with,
Yeah.
right? So every time you find a smaller length, how would you know the smaller
So
length?
minimum, yeah. So I say if this right minus left
Left plus 1
plus one,
is
yeah.
lesser than
Yeah, so if right minus left plus one is
is,
lesser than min length min.
then you
I
update
think I
your,
named it that.
yes, then
Yeah.
you update your length min and the start min, correct?
Len min is equal to, yeah, right minus left plus one.
Hmm. Yes.
And our start min is equal to left.
Yes,
Is it? Yeah.
and that's it. At the end of this while loop, you like at the end you just need to return the string. So the string you can just simply return, you have the start, you have the length, so you can return the, you
Yeah,
can,
so we can just return uh, for every character from left to right. Yeah.
right. So
So like I equals left, I less than right, I plus plus. Because right will go x will exceed, then
no,
it
you
will.
can just say s dot substring.
Wait, there's a thing like that.
So yeah, sub str method is there. You can say sub str and just put min start
Oh yeah, min start. Yeah,
and comma min length.
I think I named it start min,
Yeah, right. What
comma. Uh,
the length. So this substring method tells you like how many
oh
characters.
yeah, length. Okay, makes sense. Yeah.
Hmm.
Yeah.
If you want, you can also, let's say if you don't remember this method, because you can actually create the substring by running a for loop from starting from start min position, right? And like starting from start min index and then going running this loop until I reaches length min, right? So, and
Yeah.
then you keep appending all the characters to form the string. That's also one way of doing that. That's
Yeah.
what, in fact, the substring is going to do internally. So, in case if you don't remember this method, don't get panicked. You can do that in a for loop. So, it's the same thing.
Yeah. Okay. So I'll just submit and see. Wrong.
So,
Oh yeah, I forgot this
yeah.
the case if you cannot get anything.
Mhm.
Yeah. It's here outside. So I see, I check, like if counter is not equal to zero, and then you return the empty string. Yeah.
Mm, no, because counter might not be 0 at the end when you are actually doing this iteration, because you'll try to minimize the length of the string at every point, right? So in the while loop, you're making counter not equal to 0, right? So this is not the right
Yeah.
thing. What you can instead check is if your length minimum is equal to string length, let's say, if your length minimum is equal to string length, how do we say that? You can actually, in fact, what you can do is you can, Hmm. You can equate your start min to maybe um okay, so you can say minimum length is equal to int max initially. So you have minimum length, right? Instead of this, you can say int max, and then you can check at the end if your length min is still equal to int max. It means we have not found any solution, so we can return empty string. Is that
Okay.
Does that make sense?
Yeah, it makes sense.
Can you try to
Yeah,
submit?
because if we never update length
Hmm.
min, that means
We have
counter never hits zero, so there's no solution.
There
Yeah.
is no solution, but you cannot,
Yeah.
if you try to check for counter directly, it won't work for you because we always counter will always be greater than zero at the end. You can
Yeah,
you can
because
try
that's
to
our while loop
minimize.
condition.
Yeah, because every time counter will become zero, we'll try to keep minimizing it, right? And we'll keep shrinking the window, and then counter will finally become greater than zero itself, right?
Yeah, yeah.
And at every point, we are storing the desired output, but still. Anyway, so try to submit this now. I'll have to run to an event now, so I
Okay.
try to figure it out. I think that's a homework exercise. You know the logic. Try to correct this code. There's a small bug which I think is happening, but try to do a small dry run, correct it out, and I'll
Okay.
also send you few more questions maybe tonight once I get back. Okay, to practice.
Okay. Sure.
I'll stop the recording